Hi, I'm Alex. This is Oh, That's Why, a podcast about JavaScript, finally making sense. Let's dig in. You've written a variable. It's right there in your code. And somewhere else, maybe in a function, maybe in a loop, maybe just a few lines down, JavaScript acts like it doesn't exist. Not a typo, not a syntax error. The variable has a name, it was declared, and JavaScript simply refuses to acknowledge it from where you're standing. Most developers hit this and spend 10 minutes checking spelling. Then they move the variable. Then they add a console log. Then they get increasingly confused about why the same name works in one place and not another. The answer is scope. And once you understand it, this particular flavor of confusion disappears entirely. Scope is the set of rules that determines where a variable can be seen. Every variable you declare has a scope, a region of your code where it exists and can be accessed. Outside that region, it's invisible, not gone. Not deleted, just invisible. What determines the shape of that region? And why does it behave differently depending on whether you used var, let, or const? That's what we're working through today. Think about a building. A large office building, multiple floors, many rooms. Some things in that building are visible to everyone. The lobby, the main entrance, the emergency exits. Anyone in the building can find them, use them, refer to them. It doesn't matter which floor you're on or which room you're working in. Go up to a specific floor. Some things on that floor are only relevant to the people working there. The shared printer on floor 3, the coffee machine by the stairwell. People on floor 5 can't use the floor 3 printer. It's not their floor. Now go into a specific room. A project room, say, where a small team is working. Whiteboards, notes, a specific set of documents. Only the people in that room can see what's on those whiteboards. The moment you step out, that information stays behind. 3 levels: the whole building, the floor, the room. In JavaScript, those 3 levels are called global scope, function scope, and block scope. Global scope is the lobby. Variables declared at the top level of your file, outside any function, outside any block, live here. Every part of your code can see them. Function scope is the floor. Variables declared inside a function live on that function's floor. Code inside the function can use them. Code outside cannot. Block scope is the room. Variables declared inside a pair of curly braces, inside an if statement, inside a loop, inside any block, live in that room. They exist only within those braces. But here's the crucial detail, and this is where var, let, and const behave differently. Var doesn't respect rooms. It only respects floors. Declare a var inside an if block and it escapes the room entirely, floating up to the function level. Let and const stay in their room. They respect the braces they were declared in. That difference is at the heart of one of the most common bugs in JavaScript, and we will get to it. Here's what's actually happening. We said in episode 2 that every execution context has a scope chain, that map on the wall pointing to outer rooms. This week, we finally understand what that map is actually for. Scope in JavaScript is lexical. That word, lexical, means it's determined by where you write the code, not by where it runs. When JavaScript builds a function's execution context, it doesn't look at where the function was called from. It looks at where the function was written. The scope chain is set at the moment you type the code. It does not change at runtime. This is why you can call a function from anywhere in your program, and it will always look for variables in the same places. The function remembers where it was born, not where it was called. Global scope sits at the top of everything. Variables declared here are attached to the global object, window in a browser, global in Node. They're accessible from anywhere in the entire program. This sounds convenient. And it is, until a large codebase has different parts accidentally overwriting each other's globals. I have debugged that exact problem more than once. Function scope is created fresh every time a function is called. Variables declared inside live inside that function's execution context. Created when the function starts, cleaned up when it ends. Completely invisible to anything outside. Block scope is the newest of the three. Every time JavaScript encounters a pair of curly braces, it creates a new scope for anything declared with let or const inside. When the closing brace is reached, those variables are gone. var, as we established last week, predates all of this. A var inside an if block doesn't care about those curly braces. It floats up to the surrounding function. The scope chain. When JavaScript encounters a variable name, it looks in the current scope first. If it finds it, done. If not, it follows the chain outward. The surrounding scope, then the one above that, all the way to global. If it reaches global and still hasn't found the variable, reference error. This is why a function can use variables defined outside it. Not because variables leak in, but because the function's scope chain includes the outer scope. It knows to look there. And this is why a variable inside a function is invisible from outside. The outer scope's chain doesn't point inward. Scope only looks outward, never in. There is one bug that comes up so reliably it has its own nickname. The for loop closure bug. But before we get to the closure part, which is next week, let me show you the scope problem underneath it. You write a for loop with var. Inside the loop, you do something with the loop variable. Maybe set up a timer, maybe push a value into an array. When you check the result later, every iteration of the loop has the same value. The last one. Not the value it had when that iteration ran. I've been here, staring at output that makes no sense. The reason, var is function scoped. The loop variable doesn't live inside the loop's curly braces. It lives in the surrounding function. There is only one variable, shared across every iteration. By the time any stored reference is run, the loop has finished and the variable holds its final value. Switch from var to let and the problem disappears. Just gone, because let is block scoped. Each iteration gets its own copy of the variable, its own block scope. Genuinely separate variables. This is not an edge case. This is one of the first real bugs most developers encounter when they start working with asynchronous code. Second trap, polluting the global scope. Declare a variable without any keyword and it becomes a global automatically. No let, no const, no var, just a name and an assignment. In large projects, these accumulate, collide, and produce bugs that are impossible to trace because cause and effect are in completely unrelated parts of the code. The habit worth forming, const first, always. If you need to reassign, let. Never var in new code. And never skip the declaration keyword entirely. The third one comes up in code reviews constantly. Someone declares a variable inside an if block with let, then tries to use it after the block closes. It's gone. The block scope ended. The fix is to declare the variable before the block, at the level where you actually need it. Scope isn't about hiding things, it's about organizing them. Every variable lives exactly where it should, and can only be seen from where it makes sense. 5 episodes in, we have the two-phase model, the execution context, the call stack, hoisting, and now scope. Every one of those ideas is part of the same picture. JavaScript's scope chain is built from execution contexts. Hoisting is a consequence of the memory creation phase. The call stack manages which execution context is active, and scope determines what each of those contexts can see. It's one system. The companion article on Medium walks through the for loop bug in full, with code, with the exact explanation, and exactly what to change. That one's worth bookmarking. Link is in the show notes. Next week, closures. The moment when a room gets torn down, but somehow leaves a window open. It is the most powerful idea in JavaScript, and after 5 episodes of building up to it, you have everything you need to understand it completely. I'm Alex Vega. This is Oh, That's Why. You just connected 5 ideas into one. Most people never do that. See you next week.